Welcome back to Module 2, Physics. In this video, we begin optics, covering reflection, refraction, and Snell's law. The law of reflection says the angle of incidence always equals the angle of reflection. Theta we see equals theta r. Both angles are measured from an imaginary line called the normal, drawn perpendicular to the surface at the point where the ray strikes it, not from the surface itself. Not all reflection looks the same. On a smooth surface, parallel rays reflect as parallel rays, in what is called regular or specular reflection. This is how a mirror forms a clear, sharp image. On a rough surface, the same parallel rays scatter in many directions, called diffuse reflection. This is why most everyday surfaces do not act like mirrors, even though they still obey the same law of reflection at every single point. Refraction is the bending of light as it crosses from one medium into another, caused by a change in the speed of light. When light travels from air into glass, a denser medium, it slows down and bends toward the normal, giving a smaller angle than the angle of incidence. Snell's law puts a number on refraction, an 1 sine theta. 1 equals n2 sine theta 2, where n is the refractive index of each medium. A higher refractive index means light travels more slowly through that medium and bends more sharply when it enters it. When light travels from a denser medium toward a less dense one, there is a critical angle beyond which it cannot escape at all. Instead of refracting out, every bit of the light reflects back inside, a phenomenon called total internal reflection. Sin theta c equals n2 over n1. This is exactly the principle that keeps light trapped and traveling along a fiber optic cable. Here is one for you to try. A light ray strikes a flat mirror at an angle of incidence of 40 degrees. Find the angle of reflection. Pause the video now. Read the question and select your answer. The correct answer is B. Angle of incidence equals sine angle of reflection. Read the question and select your answer. The correct answer is B. Denser medium bends light toward normal. Read the question and select your answer. The correct answer is C. Beyond the critical angle, light cannot escape. That completes video 18. Next time we continue optics with curved surfaces and fiber optics. See you there.